Okay, so we'll start very basic and let me share my screen. Just give me a second. I hope you can see the deck.
Yes.
All right, so we'll start. So what we are going to see today, the number one, what is an agent basically? And there is something called React pattern, right? So we will not go into, very deep saying the agent is making use of memory, it's learning, reinforcement, learning, all those things. Rather, we will start with the basic things and we will try to build something and then observe. Okay, so I want this session to be, more hands-on basically, right? Instead of running behind some typical definitions of the AI agents or agentic AI, we will try to build something and see what we have built, what it can do, what not it can do, basically, all those things. So we'll start with the simplest definition of an agent. What is React pattern? Then we will set up our project using Grock API. So Grock is a platform which basically hosts open source models, open source LLM models. So we will use that platform to use one of the models which is deployed on it. And then we will create one class-based agent. Okay, so in this class only, we will create one agent, one basic agent, Python-based agent, and we will build what should be its system prompt, how to create the agent tools, the chain of thoughts demo, and running the agent in a loop. So all these things we are going to cover today. Anyone has any questions before I proceed? All right. So let's try to understand in a very simple or in a very broad manner what an agent is. So you have seen, right, most of the time when we are interacting with the chat GPT, the chat GPT is what? Chat GPT is an application, full-fledged application, which basically has a lot of agents also integrated, and it has one LLM as well. LLM is your large language model. For chat GPT, that model is basically GPT 4o mini, or we can also select the model sometimes. So there is a large language model. And now in what they are doing is, if you have seen the launch of GPT-5, they are also giving you a team of models basically. Sorry, no, I'm deviating from the topic, but in the GPT-5, what they are doing, they are giving you a team of agents. And what will happen when you ask a question at the runtime, they are going to decide which model is the best one to answer your question. If it needs reasoning, it will go to the reasoning model. If it's a very straightforward question where it can give you the response in a very quick manner, then it will go to a different manner. Okay, so that's a different thing. But all in all, in ChatGPT, you have a lot of agents. One agent may be, if you ask a question, it may go to the internet, it will search for some information, and so on and so forth, right? So my statement is, if you are asking a question in the ChatGPT, it will give me some response, and then I will feel, okay, this is not exactly what I am looking for. I will top up it with another question. I will ask, okay, instead of giving me the information in this style, add this information also. And then again, my question will go to LLM. It will rethink, it will generate some other response. So there is always a to and fro. right? Maybe after couple of messages being exchanged between you and the LLM, you are able to get the final answer, isn't it? Let's say you want to write some code. So first of all, and even if you compare it with a human being, right? So all these things which you see today, they are somehow inspired from the human beings. Human beings can see, so they have developed computer vision, right? Human beings can understand the text, they can read the text, they can hear the text, and that's why all these capabilities are now built in the AI applications. The AI applications can listen also, right? They can see also. They can analyze the images. They can analyze the video also. They can remember the things also, right? So if we as a human being are said, okay, you write some code which can send an email to so and so person, then what we will do? It's not like that we will start from the first line and we will be able to complete our code in just one go, isn't it? Maybe we will write something, we will try to run it, we will get some error, then we will change couple of lines, we may go to the Google to find the correct method or API, then we will try it again, we will test it couple of times, right, before we get to the final version. Same is the case is when we are interacting with the LLM with any problem, what we want is before arriving to the final conclusion or the final answer, there is a lot of iteration which goes between you and the LLM. Agree, guys? So if we can automate this loop, right? If we ask a question and if we get the final answer in just one go, then that automating that loop is basically an agent. So we can create some agent which can automate this loop in a very broad term. This kind of application which can automate this loop is known as the agent. Okay, we will see some example so that you understand it well. Before that, there is a very rudimentary way to implement the agent is a React pattern. There is something called as the React pattern, and I have also included one research paper. So if you go to this paper, just a second. Can you see the browser? Chrome? Yes, no.
Yes, you can see.
Okay. So there was a research paper basically on React. Okay. So React is what? It's a pattern. It's a way to implement or to build agents. What does that mean? It is the combination of two things. One is the reasoning and other is the acting. Okay. The core idea is an AI agent does not just react blindly to data or prompts. It thinks first, then acts, and then loops this process to refine its decision. Okay. We want to give this capability to our applications basically, where it can reason, it can think before giving me the final answer so that my effort is minimized. I don't want to prompt it or tell it this is how you need to do is. You also need to add the logs, you also need to add the comments, and then finally it will give me the answer. Rather, what I want is my application should be smart enough to incorporate all these things by itself. And how that is possible? One way is to use the React pattern. Okay, let me show you this particular diagram. So in React pattern, what happens is there is a loop basically, right?
Very good. Super. Hmm.
Please mute yourself,
No,
guys.
amazing. Zing.
Okay. So there is a loop basically, which we are trying to automate. What is the basis of this loop? There is a thought process which our LLM will do. When we ask any question, we want our large language model to think through that particular question. Okay. And then it will take some action. First of all, it will tell us what is the right way to achieve that particular goal. Okay, whatever question we have asked, it will think through, it will reason, and then it will tell us, okay, this is the tool which we should use in order to accomplish or to answer the question. Once we execute that particular action or tool, what will happen? It will give us some output which is called as the observation. Okay, once we get that observation, we basically pass it again to the LLM for its thought process, whether the goal has been achieved or not. So this is a loop. If it thinks, okay, my task or has not been achieved, my goal is not been achieved, then it will again take some action, decide some action, execute that action. We will get some output, and that output is again fed to it, and it will go on. Right? This loop will go on until we achieve our final answer. Let's take an example. Let's say as a user, I'm asking a question saying that what is the total mass of the earth? Okay. If I ask a question, what is the total mass of the earth? And if I design my prompt, first of all, in order to build such agents, we need to design our application. And the most important part is how you build your system prompt. In the system prompt, I will say you work in a cycle or a loop, and the cycle is of thought, action, and observation. We are giving instructions basically to the LLM saying that you basically work in a loop where you need to think something, you need to action, you need to pause, and there is an observation also. The cycle we have just shown, we are explaining this thing to the LLM, and then by the end, you have to give the final answer. Here are your total available actions. Okay, actions are basically whatever you want to do, whatever action you want to do, those are called as action. For example, if you want to call search Wikipedia, then this is one of the action. And this action can be accomplished in the form of tools. We have to build some tools and we have to associate it in our application so that LLM can choose one of those tools. Is it clear, guys? What is tool basically? Tools are nothing but they are Python functions which we create in our application, and we tell our LLM that you have access to these tools. The tools can be, for example, there is a tool called Search Wikipedia. With the help of this tool, we can search on the Wikipedia. There can be another tool which says do math calculation. So with that tool, we can do some mathematical calculation. There can be another tool which can tell us the weather of a particular city. So that tool will take city as an input and it will give us the weather conditions. So these are nothing but they can be API calls also, right? Lot of websites basically expose their methods, their functionality using APIs. So we can use those APIs and we can write any custom code that will act as a tool. Okay. So we build a system prompt. We say that you work in a cycle and you have to think, you have to take action, you have to do observation, and in the end, you have to give the answer. And these tools are available with you. Now answer this question. Okay. So when we ask a question like, what is the total mass of the earth? What will happen? Along with the user question and the prompt, everything will go to the large language model. And now what it will do is, as per the instruction, first of all, it will do thought process. It will see, okay, I need to find the mass of the earth. Then it will decide that this is its thought. I need to find the mass of the Earth. As per the question, its thought process is okay. This is, I need to find out the mass of the Earth. Then it will decide what action it has to take in order to achieve this goal. It will say, okay, from the list of my tools, I have a tool called Search Wikipedia. I think I should call Search Wikipedia and should give the mass of the Earth as an input. Okay, so it has done thought process and it has done action also. It has decided the tool name. And once the response is given back, what we need to do is we need to call that tool by providing the mass of the Earth. That tool will get executed. Tool, which is a Python function, it will get executed. It will return the search, the results. It will say, okay, 5.9 into 10 to the power 25 is the mass of the Earth. And the response will be returned. So this is what the output is always observation. Your output of the action is observation. So this observation is passed back and this will be passed again to the LLM. And LLM will see, okay, this is what I have got from my tool. Is it the final answer? If yes, it will break the loop and it will give the final answer to the user. If not, then again it will go into the loop. So let's say my question was, what is 5 times the mass of the Earth? Then first it will calculate the mass of the Earth by going to the search Wikipedia. Then it will see, okay, since I have got the mass, now I need to multiply it with 5. What I can do is I can create another tool which is like multiplication tool. So it will use that multiplication tool to again go in the loop and then multiply the mass with the 5 and then it will give us the final answer. Is it clear or not, guys? No? Yes?
No, it looks okay.
Yeah.
But how to calculate the
Okay.
mass of the Earth?
Yeah. So that's what I will just show you. We will basically build a lot of tools. Those tools will be able to calculate
Just
the mass,
just
right?
one question, sir.
Uh-huh.
How it will decide which tool we have to which tool we have to use to calculate the mass?
Correct. So that's what we will do. While writing the prompt, we will write here the name of the tools and we will also describe a bit about these functions. These are what? These tools are nothing but the Python functions, right? Internally, they may be
Mhm.
calling some API, they may be going to some database or anywhere, right? We can write our custom code as well. So this tool will do, we will write here what are the input parameters of this search Wikipedia and what is intended to do. Okay, we will write
And how to
some,
break the rule, how to break the cycle that this is the correct
it
weight.
it will do it itself, right? LLM. That's what we want, right? We don't want to interact ourselves. We want to save our times. We want to use the mind of the LLM to decide which tool to call and when to stop, right? That's what we want to do, right? We want
Yeah,
to
but
mimic.
there might be there might be multiple tools which are used for same set of purpose, right? Means like you said, to get the mass, that is using the search Wikipedia, right? But
Mhm.
there are other ways. There might be some other tool also which is giving the mass or something like that, right? So
Yeah, I mean,
how does it is
yeah, I mean,
decided by the
yeah, when we design our application, we will give only those tools which are useful, right? Why we will write multiple. So it's not deciding by itself or not creating the tool by itself. We will write these
Mhm.
Python functions and we will put it in the system prompt. I will show you today also how to build the entire application. Okay, we will write these functions and we give the name of these functions. Why I will create search Wikipedia 3 or 4 times or like calculate the mass of the Earth. Even if I do that, I will clearly give instructions when to use which tool. Even I don't want to confuse my LLM, right?
Yes,
LLM is
yes.
very good at understanding the natural language, I mean, process, the natural language, so I will clearly tell that you have to use this tool only in this condition, another tool in this condition, and so on and so forth. My instructions are very important basically. How I describe my tools and functions, that is very, very important. Otherwise, as you said, it may get confused. Okay. So this power of
So
human being,
is it,
right? Yeah.
sorry, last question. So what we are saying, the system prompt is more defining the scope of that
Exactly.
app, right? Is it what we are saying?
Correct. The system prompt, even if you develop any application using large language model, the system prompt is
Mhm.
basically heart of your application. It will control the behavior. It will decide the persona, right? How LLM has to behave, how it should think. The entire logic we are telling, right? How it has to work. It has to work in a cycle, thought, action, and observation. If you skip this thing, then it will behave in any abrupt way, basically. We have no control. So controlling the LLM behavior is based on system prompt only. Okay.
Okay, right.
So let me see. So let's again see the React pattern. You know what we want. Reasoning. The agent performs internal thinking like analyzing the situation, weighing options and coming up with the hypothesis, right? If we have a complex task which includes maybe 5 subtasks, then it will break the task into 5 different subtasks and then it will try to do the task one by one. Okay, first it will calculate the mass of the Earth. If I say give me the total mass of all the planets, first it will calculate mass of all the planets and then it will do sum. And if we say multiply it by 5, then it will do the multiplication. So whenever we give a question, it breaks it down into subtask and it will try to execute it's one by one. Right? Just like we as a human being, if we are asked to write a piece of code, we will do in the similar fashion, right? We will write something, then we will test it. If it's not working, we will try something else. If we are also asked to calculate the 5 times mass of the Earth, we will go to the Google, right? We will just say what is the mass of the Earth. We will get the mass. Then we will open calculator. We will multiply it by 5. So that's what our intention is. We are trying to automate all these things by building these agents, right? And we are giving that power of reasoning and then taking decisions also. So based on the number of tools we have associated, it can, first of all, LLM can reason how it has to accomplish the goal, and then it can also decide which tool it has to use, basically. And then it will do acting. It will say, based on the reasoning, the agent performs actions like querying a database, calling an API, interacting with the tools, or collecting more information. The agent keeps doing this in a loop until it achieves its goal. Why it is important? Input, reasoning, action, observation, more reasoning, better action, final output, right? This is super helpful because the agent can handle incomplete or evolving tasks. It mimics human-like problem solving. It allows agent to verify its own step, reducing errors. So these days, we don't want LLM to give us the answer quickly. If your manager is saying, write a design document or create some technical specification for a project, he does not want you to do it in a single hour, right? He gives you a couple of days. Similarly, we don't want the answer from LLM in a very fast manner. Rather, we want it to do it slowly but accurately. Okay, whatever output it is producing, we want it to analyze himself first, whether it's correct or not. If it's generating code, then it should reason itself. Has it complied all the code writing norms? Are there comments are there? Is it indented well? Right? Have you used the best practices for the Python? And then it should give us the final answer. Useful for complex tasks like research, multi-step reasoning, decision making, interacting with the multiple tools. Okay. This is also the same thing. For example, if you have a question like, what's the latest paper on quantum computing and can you summarize it? So what it will do is it will reason, to answer this, I need to find the latest papers. Okay. And then what action it will do is search an academic database. Observation finds a paper. Reasoning, now I should read and summarize it. Then it will read the abstract and main points. Observation, the output will be get the summary, and the final output is presents summary to the user. Okay. So let's do some hands-on. So we will use Grock API. Let me see. Let me open VS Code. Anyone has any questions? So I just wanted to start in a very simple way. I don't want to overwhelm with you a lot of information. Otherwise, you will get confused. Or
Surendra, is a ChatGPT application technically an
Mhm.
agent?
Yes, it's an agent. It is comprised of multiple agents which are running in the background. If you do a deep research, then something else is triggered. If you do, you can choose the data source as well. If you say what is the temperature in Delhi, it will use some weather API, right? So there are a lot of things which are running behind the scenes. It's not just the LLM. LLM is just one service which it is being using. Otherwise, there are multiple agents.
Okay.
So
Thanks.
the other way I can say that whatever the data Google has collected since like 2005 or something when it started,
Mm-hmm.
uh, all the data this ChatGPT has by now already have, right?
No, why?
Because it searches own database or it searches from the Google. If I ask some question.
Mm-hmm. Yeah, I mean, it can search the internet, right? So there are APIs basically. If you see, there is something called SERP API, SERP API. It can use SERP API to search the web, right? It can use Google APIs to search. So those integrations are there. So you cannot say it has access to each and everything. First of all, your LLM is being trained, right? So a lot of things depends how your large language model is trained with which information. But once this training is complete, it has no information of the current events, whatever events which has occurred past its training, right? So for that, what it can do is it can use some web search kind of things. It can go to the internet, it can search the latest event, and then it will find there are 10 resources which are talking about this one. It will collect that text, it will process that text, and then it will give you the final answer. Okay.
So suppose by any chance, say for example, ChatGPT reaches certain websites for
Mm-hmm.
certain data, and
Mm-hmm.
by any chance the traffic to those websites or is not good. I mean,
Mm-hmm.
very high traffic, or some websites from where it used to collect the accurate data, and those websites are down. Then
Mm-hmm.
in that case, what it will do?
So I mean, it will just try to do whatever best possible it can do in the real time, right? If that website is down, then it will look for some alternative, right? Some whatever information is available on the web, it will use that in that case.
Okay, so you're saying that ChatGPT relies mainly on internet,
Yeah, I mean, it
or
depends on your question, right? If you're asking a very simple question, or maybe if you ask, tell me about Sachin Tendulkar. So maybe LLM, the GPT models are already trained on that data, so it will give from its own trained data, right? It will tell you some history of Sachin Tendulkar, where he was born, who was his coach, when was its first test match, all those things. If it needs to call anything from the web, then it will call that web agent to get the information. If not, then it will not, right? It dynamically
okay.
decide basically.
But I think there was an announcement like ChatGPT 2 or 3 has certain data till 2022. So
Mm-hmm.
it means ChatGPT does not have the latest data. So I was under impression that it has all the data, a copy of data available in ChatGPT server, not relying on the internet because they were saying so.
No. See, first of all, there is nothing like copying the data. Okay, either the LLM has been trained with some data, so it has knowledge of that particular data. It's there in its model's weights, basically, that information, or it is going to the internet to search the data. There is nothing like they have saved some data into their database and they are querying there. I mean, I have not heard, at least. So this is not the case. If the model is trained till 2022, then that large language model, GPT-4o, 4o mini, whatever model we are using, that model will give you some answer. And if it is not trained on that data, then it will go to some other tool or agent to get the data from the internet.
Okay, thank you.
Yeah. All right. So are you guys clear about what is agent? I mean, I did prepared some other PPTs, but I thought maybe you will get confused. So if you want, I can go through those PPTs as well real quick. If you are still not able to relate, or it's good enough. Let me show you basically. I hope you can see my screen.
Sundar, I have one question.
Yeah, please.
So you mentioned like we can create a one agent and they connect it to LLM automatically.
Mhm.
And so how to decide? Like suppose LLM doesn't know what is my needs. Might
Mhm.
be you mentioned like about what is the mass of the Earth, but
Mhm.
after that, but suppose I want to display some reports on basis on suppose a year 2025. These are my actual you can say demand.
Mhm.
But you said like LLM decided what is the actual you can say what is the best possibility for me.
Mhm.
Because I
Correct.
want to know like someone has asked you a question how to break this loop through.
Mhm.
Decide based on
Yeah.
the our requirement or based on the LLM.
No, see, if you ask one question that prepare a report for 2025, then first of all, what it will do is it will break your question into some different subtasks. Okay. And this is all based on its reasoning capability. So now the models which are being released are having reasoning capability. Okay. So what does that mean is they will create some chain of thought. Okay. In order to create a report on a particular topic, first of all, it should have some information, right, on that topic. Let's say you want to have some report on AI agents. So first of all, it has to scrape the internet and get those research papers, right, where there is an information on AI agents. So first it will, so the first task is to pull the reports. So it will go to the internet, it will go to the archive.com, it will download the reports and it will have access. Now it will decide, now I need to read those reports. So it will read the content of all those PDFs which it has generated. And third will be to create an outline of the report, right? So it will create some outline of the report. Fourth is to fit the content into those outlines. Finally, it will give you the report. If you want it in a document format or a PPT format or PDF format, it will finally draft the report. And once it is able to do all its tasks, then it will exit that loop and come out basically, right? Let's say as a human being, I have to bake a cake, right? So now what I will do is, okay, I need some milk, I need some flour. I will think myself, right? In order to bake a cake, I need these items. I need eggs, I need sugar, all these things. You will make a list and then you will say, okay, my first item is milk. In order to get the milk, what I need to do? Either I will go to my fridge, I will see if there is a milk. If not, I will take my mobile, I will order 1 liter of the milk. Once I do that, once I get the milk, I will go to my second item. I will say, okay, now I need sugar. Is it available at home? Yes, that's fine. Now I have the sugar. Go to the third step like that. Just like human beings think and decide what to do, it will execute those subtasks one by one, and finally we will prepare a cake, isn't it? In the same fashion, LLM also do the same thing. They will take your task, it will break into smaller parts. It has access to lot of tools. It will decide which tool is the best tool to accomplish a given task. It will call that tool. That tool will give the output. It will analyze the output, whether that output is good enough. If not, then it will again think something else. What is the best way to achieve? Still, it has not given the right answer, then it will try to maybe invoke some other tool, right? That's why building AI application or agentic application is not easy, because it is dynamically reasoning, dynamically deciding which tool to call, and then deciding by itself. So in order it's very important to create those guardrails and those conditions so that the behavior is basically controlled. Okay, does that answer?
Guardrail means some conditions we have to provide, like
Correct, correct.
where we have to go or what kind of data we can bring it. So, one question. So,
Mhm,
how to decide the pricing? I'm talking about, suppose LLM breaks this my particular task, might be 100 subtasks.
mhm,
Might be some of the tasks they are directly reaching to the some website which
mhm,
are taking some money, or other website might be Surrender. You have to maintain your content, but you have want to the some payment.
mhm.
These kind of things also involved. Then how to decide the payment? Who can pay, or only for as an agent we have to interaction, or we have to only token based? We have to decide it. Yeah, we need to pay more extra money for LLM or another subscribers.
Correct, good question. See, there are two things involved. One is the LLM price itself, right? Whenever we are using any LLM, let's say I am using GPT-4o, who is doing reasoning and thinking and deciding, then my first cost is the cost of the tokens which it is using. And there is a very good point. When we are using the reasoning models, there is one hidden cost, right? If we use non-reasoning model, then we are giving some input tokens and we are getting some output tokens, right? And my total cost is the cost of the input tokens. Let's say my input tokens were 50 and my output tokens were 100. So my cost was based on these 150 tokens, correct? Now, when you start using the reasoning models, there are some reasoning tokens also, which were basically, I I told you, right? It basically creates some chain of thought. It thinks through the entire problem. There are reasoning tokens also, so that cost is also involved. Okay, so it will, whatever tokens or whatever iterations it will do, your cost will increase. Basically, your LLM cost will increase. Okay, so it is very important to keep a check or keep an eye on your token cost when you're building AI agents. Sometime if they go, I mean, if you have not built your AI agents in a very controlled fashion, you have to put some condition, right? Maximum iterations is 10. We will do it today, by the way. Maximum iterations equal to 10. If it has crossed that number of iterations, maybe you want to exit. If you don't give, maybe it will go into some infinite loop because of some flaw in your code. And if it goes into some infinite loop, it will use infinite number of tokens and your pocket will get burned. So this is regarding your LLM cost. Second thing you asked is, what about if my agent wants to book a ticket, right? So I will be having one agent. Let's say I have created a multi-agent application and one agent is there to book the ticket. So now it depends on what liberty or what conditions I have given to my agent to book the ticket or not. If I have already put my credit card details, given that to my agent, then it will do the entire thing by itself. If not, what I can do is there is something called human in the loop. Okay, human in the loop in the sense, at some critical instances, you want your application to prompt the user asking its final permission, whether you want to go ahead or not, right? For example, before booking the ticket, it will prompt you, this is the ticket I have finalized, this is the time, this is the flight, this is the airline, and this is the cost of your ticket. Do you want me to book the ticket? I will say yes. Then either it will do the payment by itself if you have given those permissions and credit card details, else it will give you on the browser, it will show you the payment gateway where you can put your details and you can get it done. But giving this autonomy to the agents that it should go and put your credit card details is very risky. If you have seen the last video from the OpenAI, I think it was released a month back. They have also given this disclaimer that don't give this kind of autonomy to your agents, otherwise. So they also shown the concerns that you have to be very careful. Better is to give human in the loop kind of thing where human can go and decide or put his credit card informations. Okay, so there are two costs. One is the token cost, other is if it is going to a particular website and it's being chargeable, how you want it to behave. That's up to the developer, how you develop your application. Does that answer your question, Jagdish?
Yeah, clear. Thank you.
Chalo, without further ado, let's build the agent. Okay. So what I will do is I have my VS Code. Let's do step by step. Let me create another folder. Open folder and let's build workspace 4. New file, let's say I name it IPYNB, Interactive Python Notebook. And my first job is to create my virtual environment. What I can do is Python -m venv4. It has created this virtual environment, which is venv4. This is the name which I have given. So, I mean, I initially, create a lot of content, but I thought maybe it will confuse you guys. What is an agentic AI means? Giving these agents the autonomy. Autonomy means the decision power. They should be autonomous. They should decide themselves what to do. Second is goal-oriented behavior. Whatever question we ask, it will basically try to achieve that goal. Environment interaction. So if it thinks, okay, I need to go to a particular database, let's say I have given it the access to my Gmail. So it will go to my Gmail, it will read the email, and it can also reply. Okay. The learning capability, the best thing the agents can have is the learning capability. Based on my past interactions, it can learn, right? Let's say every time it decides to book a ticket, I say, no, I want to prefer this type of airline, right? I always want to travel in the Air India. So it will, by my past interactions, it will learn, okay, Surendra always love to go with the Air India, not the Indigo, things like that. Okay, so that's what we call as a learning capability. Just like human being, right? We learn from the past experience. So this agent will also learn from whatever decisions we have taken in the past. It will store those into some database. That's what we call as the memory. So these have memory so that they can give you the best possible experience. Okay, it will not always tell me, should I book the Indigo ticket, right? It should understand that, okay, I'm always preferring Air India. So it should give me that option only. That's what the learning capability by reinforcement learning. Workflow optimization, which route it has to take, to automate the things, multi-agent and system conservation using multiple agents, right? And why the organizations are running behind these AI agents? Because of enhanced decision making. Because of these agents can boost efficiency and the productivity, improved customer experience, right? And how these agentic AI systems are different. If you look at the history, what we had been developing so far. So I'm just quickly going through, right? So that if you are disconnected still, it will help you to, join the dots, basically, connect the dots. So this is, earlier we were having these rule-based chatbots, right? Where we used to create some rules, predefined rules. If my input is X, then I have to perform step number 1. If my input is something else, I have to do something else, right? Those rules which we need to decide earlier while creating the chatbots. But they fails whenever the user asks any question which does not fall under the given rules. Correct? Then we started building RAG-based chatbots where the chatbots were having access to some vector database. But these also fail in accomplishing the user intent, mismatch user intent. So what we have started, we are building agentic AI systems. They understand the nuisance in the language, handles complex and unseen queries, highly adaptive and precise. Okay, complex, it will break the task into multiple tasks. It will have other agents who can do the task better. Highly adaptive, based on your feedback or your answers, it will adapt over the time. Okay, he loves Air India, so I should not give him an offer of Indigo. Precise. Okay, contextual coherence, linear scripting. In rule-based chatbot, we do linear scripting. Poor at maintaining conversation. May RAG-based can produce inconsistent replies if retrieval does not consider prior context. Okay, so these are a couple of reasons why the industry is basically running behind the building agentic AI systems. Customer experience, they were like 24/7 basic support, but rigid. They are quite rigid, right? Sometimes they are frustrating. After asking couple of questions, you will be getting same answer and you may fall in some loop, right? Maybe your question is not listed in the given list of frequently asked questions. Then the customer get frustrated. Okay, I hope everyone has experienced this thing. More human-like interactions, but can still break down in complex cases, right? What if I have asked a question which is not in my vector database? Then how to handle such situations? Either it will hallucinate or it may not be able to give you the answers. In the agentic AI system, it's fluid, solid, solution-oriented conversations, high engagement, responsiveness, and satisfaction. Okay, so this is how this chatbot technology is changing, evolving over the time. Let's take another example to understand this more accurately. Let's say I have a customer support agent. Okay, so this is my master agent. There is something called orchestrator agent. The job of this agent is to do the coordination between multiple agents. So what I can do is, these are micro agents. One is the user experience agent, other is the frequently asked question agent, issue resolution, right? Status update agent. So I can build different agents who are specialized in different tasks.
Yeah,
Got
it
it?
looks like a project manager team lead.
Exactly. I mean, this is what their aim is. They actually want, let's say, I will give you one more scenario. Let's say most of us have done some production support, right? So what we used to have some tool where we used to get the tickets, right? And then, I mean, I have worked at least in 2006, 7, 8. I used to work in a support team where we used to get the tickets from the users. So once I open that ticket, it's At the initial stage, it's in the new state, right? It's a new ticket. Its status is new. Then I will read the content of the ticket. Then I will see, okay, user want to have some access rights. Some maybe the right now the user is a read user. It has read access. Now the user wants write access. So I will say, okay, I will classify my ticket into a certain category, right? I have other team members who will resolve, but my job is to classify these tickets. So what I will do is I will classify the ticket, and then I will route it to a some other team. Okay, this team basically do the user management, so I will route it to that team. Next ticket I have got
LDAP, yeah,
LDAP or whatever. Yeah,
or Windows access.
LDAP team, right? Who will give the rights and access. Next ticket I have got, they are not able to view some documents, so I will forward it to some database team or some, some arca, some file management team, right? Maybe those that backup is not being restored or something. So I will put some other team name and will route it. So now what I can do, I can build these agents who can classify your tickets by using these agents. Okay, the agents already know, it will read the content and it will be able to understand, right? So now you can see these LLMs can understand the natural language. If user has written a description that I want to have some these rights, then the LLM will read the description and it will decide, okay, this ticket should go to this team. So that automation has been done. Yes or no? So earlier there were 5 people in one shift, and if they are supporting 24/7, there were 15 people who were doing only this routing. So now that has gone. Right now there is an agent who can work 24/7. It will not ask any breaks and not salary also. So it will take the tickets and it will route to a different team. Now at the team level also we can build some agents. Instead of that team, I can easily give rights to a particular user. If I am giving the user ID, I can give it to some proper rights, right? So those kind of automation I can also do. So my user management agent will give the proper rights and it will close the ticket. Okay, let's say so I have two agents. One is the classification agent, second is the resolution agent, and third, let's say that second agent is not able to resolve the issue. What it can do is it can now escalate to some human agent basically. So I can create this kind of layered solution where if our agent is not working or if we have not tackled that particular scenario, then only it will give it to the human agent who can basically look into the issue personally. Okay, so this is how the things are changing all over the world. What is an agent? So this is another definition: a system that can reason, plan, take actions on its own based on the information it's given. It can manage workflows, use external tools, and adapt as things change. A digital employee. So an agent is like a digital employee that can think, remember, and get things done. It's like a human. Again, this React pattern, this example. So what are the main components? It has a brain, just like human beings have a brain. The LLM will act as a brain who will do the reasoning part, planning part, and language generation. The humans also learn from their past experience. Similarly, they also have the memory. It gives the agent the ability to remember the past interactions to give you better experience. Right? Remember that Indigo and the Air India example. It has tools, how agents interacts with the outside world. If I need to use Wikipedia tool or I need to do calculator, whatever. So it will be able to use those tools. Okay.
And the brain, can you please go back?
Yeah.
Brain, LLM, and memory will be implemented using which language? Like we learned that tools will be used.
Correct.
Python, right?
Yeah. So LLM is your LLM, right? This is large language model of your own choice. You can use OpenAI models, you can use Google models, Gemini models, you can use Claude, whatever, right? Memory is what we will use. We will use the framework of the LangChain and we will build the memory. And I will show you all these things. Okay. So this can be a database also. It can be a temporary memory also. It depends what kind of application you are using. Okay. It can be Redis or whatever. there is little bit more on the tools. What kind of tools are there? Retrieving data or context. Let's say even this RAG can be a particular tool. If I am designing a one agentic application, the RAG can also be part of it. Retrieving data or these tools can retrieve data or context, searching the web or pulling info from a document or a database. Taking action, they can send an email, update a database, create a calendar event. I want to book a ticket, then it can book a ticket as well. It can look into my calendar, it can schedule a meeting, things like that. Orchestration, calling the other agents, triggering workflows, and chaining actions together. So these are the different possible tasks our tools can do. Agent types, again, it can be a single agent, it can be a multi-agent, right? Multi-human system, just like there is a task, there is a supervisor, there are research human, sales human. Now, in all these guys will lose their job. We will have research agent, sales agent, support agent, and solution. Okay, just kidding. So this is how, but this is how the direction in which the industry is going.
So earlier, when IT started coming, then companies started hiring software engineers, right? Now it is going in the reverse direction.
Yeah. I
Minus
mean, there are a
part
lot
of the
of
job.
companies who have already said, right, they are using 7,000 agents, 8,000 agents,
IBM,
right?
IBM
Yeah,
implemented,
IBM
yeah,
or yeah.
HR
So,
agents. So can
so
we go back a little, one or two
mhm.
slide? I was thinking,
This one?
okay, in this here, I asked the question like LLM will be in the loop, right, till it gets the correct data. So at what point LLM will decide that this is my correct data?
So, I mean, that's what we are saying, that LLM is the brain basically. It has to decide by itself, right? If I want to calculate the mass, it will be dependent on search Wikipedia tool. That tool will be invoked and it will give it the answer, right? So it has to trust these things. If these tools are not good enough, then LLM cannot do anything, right? Without weapons, you cannot win the battle,
Yeah.
right? So you should
Yeah.
have right set of tools so that it can achieve the goal.
Okay, so thank you.
Okay. So the guardrails, you have to put basically all those conditions, as Jagdish was saying. To book the ticket, it will put your credit card informations and it will, so you have to put those conditions there, right? You have to put those guardrails. So, okay, key terms, HTTP. So this is how they call basically these APIs. You have a weather agent and it will do some get HTTP request. It will go to the weather API. It will call the method get weather. It will give the response back in the JSON format. Okay, you can have agents who can behave as a personal assistant, social media manager, customer support, research agent, travel planner, and much more. There are some few examples. This React agent we have seen. All right, so we will do all these things. We will use in this course, we will use a LangGraph. LangGraph is a framework built by LangChain company. So we will heavily rely on the LangGraph. This is very good framework to build the agents. And in the next lecture, we will see how to create those workflows and agents, how to put those conditions step by step. Or let me show you in my another slide. LangGraph agents. Okay. In the next lecture, we will see how to build these kind of workflows where you decide the control of your entire application. Start, there's an assistant tools, come back, enter right sequence, right assistant, right sensitive tools, and finally it will end. So we will build these, we will create these nodes. This is called node, right? They can be your Python functions. Your agent will start, your workflow will start, it will go to the first node, It will do some processing, and then based on certain condition, it will decide whether to go to node 2 or the node 3, and then it will end, right? And we talked about tools, right? So we will create some tools and we will associate those tools with the LLM, and then LLM will decide which tool to call, right? It will call some tool, it will give the answer, it will analyze the response. If it is good enough, it will end. If not, it will call another tool, and so on, right? So the complexity depends on your application, what you are trying to build. But this is how we create agents in the LangGraph, which is a framework from LangChain company. Okay, so now let's quickly go to our VS Code, our IDE. My virtual environment is created. My IPY file is created. And instead of writing each and every code, let me paste. So my code is also there on GitHub. Okay, so introduction to LangGraph, what this is having. No, this I don't want. Without loop. Okay, so let me first tell you how you can get access to the Grock. Okay, our models basically. So I will do is Grock documentation. So everybody knows by now, I think, what is Grock. Grock is a platform. It's just like AWS or Azure. It's a platform where what they have done is they have hosted couple of open source models. Okay. And we can invoke or inference those models by calling the Grock API. Okay, so if I click on quick start, it will say if you want to use, you should have pip install. You have to or before doing that, I need to do what? Activate my virtual environments. Once I activate, I can see the name of my environment in front of this one, and then my documentation says in order to use the models deployed on Grock, I should install the library. I will do pip install Grock. You may have installed in the global environment. Please mute yourself, everyone. My library is installed. My environment is V and V4. Okay, so I will select that environment. We'll just print hello. It will do some installation again. So what I'm trying to do is I am trying to set up my LLM, right? For building agent, we need a large language model. So I have come to this Grock quick start documentation page. I can see the code. I will copy this piece of code and will go and put it here. Before that, let me also create one .env file where I will keep my secret keys. What secret I want at this moment? I need Grock API key. I will select that. I will put it here. From where I will get the value of my API key. For that, I can go to API. I have to log in with Google. I will create another key, AI agents. I have copied my key and pasted in my .env file. Okay, so in the .env file, I will put all my secrets or variables which I can load in my application. So for loading, what I need to do? I need to do import OS. Before that, I need to install another library, pip install python.env. Okay, so python.env is used to load your .env file. It's done. Now I have done import OS from .env, load env. Okay, I am using this Microsoft Copilot, which is suggesting me the code, making my life easier. So I will run this one. My .env file has been loaded. Now I can use the variables which are there inside. I am importing who is Sonika Sharma. Who is that? बच्चे भी ज्वाइन कर रहे हैं क्या क्लासेस? Okay. How to erase this one, guys? What is...
I think possibly you can try to reshare.
Sorry?
I think you can possibly try to reshare your screen. It's, I think,
Okay.
annotation.
Okay,
So
annotation should be there.
annotation, you can, I'm just guessing.
There should be some eraser or something.
There is a there
Disable
is a pen
annotation.
called annotate, and somebody has used it. I think Sonika or something.
Okay, यहाँ पर है ना. I will use some this one.
Maybe you can click on right.
Got it.
Oh, wonderful.
Chalo. My kid can do this job better than me. Anyways, chalo, I have got this thing. Now I will simply run this one. So what it is doing, we are creating a client, which is nothing but my large language model. I'm using the Grock. I have provided my API key, and then I'm saying client.chat completion API. And within that, I'm giving the messages. My role is as a user, explain the importance of fast language models. This is the name of the model. You can choose any model which is listed on this platform. If you go to the models, you can choose, right? So recently you must have heard that OpenAI has also uh, released one open source model. So that is this one, OpenAI GPT OSS 20 billion, 120 billion. If you want to use these also, you can use, I think. Otherwise, this is the list of models. You can use any of these. You can use some Chinese models also. What was its name? That also you can use DeepSeek. Okay. So you just need to copy their names and you are good. So let me use this one, 70B versatile. This is already versatile. Okay. This is from Meta, your Facebook Llama models. So the name of the model and the keys are provided. And this is print, chat, completion, choices, messages, and content. Your message object has basically two parts, role and the content. I am tapping directly into the content part, and this is my response, basically real-time interactions and blah, blah, blah. Okay, so this was my question and this is the response. So I can inference my Llama model. What next I will do is, now we will create the agent. Okay, in order to create the agent, I will simply copy this particular thing. Instead of writing, it will take a lot of time, but I will explain you. And we are on the way to build our first agent. Okay, so I have created a class called agent, and it has init method, which will do what? Whenever you initialize your agent, it will get invoked. And when you call your agent, this method will get invoked. And this is your execute method. Okay, so I'm creating a class with 3 different methods. One is the init, other is the call, and third is the execute. Now let's see what they have. Initialize means whenever I am initializing my agent for the first time, I am giving it the client, which is Grock. Right? I'm saying that you have to use the Grock model, and I'm also giving it the system prompt. Okay, the prompt which we saw in our PPT, where it is. This one only. This prompt basically. Okay, these are instructions to my LLM. So that system prompt I will provide to my this method. And what it will do is self.client. It will set the client, the Grock client, which we have initialized here. This client. If you want to use OpenAI models, you can do that. And the second argument is your system prompt. Okay. Once you do that, what it will do is, and there is a messages where I will keep on appending my messages. So whenever you are doing conversations with an LLM, for LLM, it's always a new instruction. It does not have a memory. So it will not remember your past interactions. Rather, what we need to do, we need to keep on appending those previous messages and need to give it to the LLM again and again. So I'm created this list, and this is right now empty, and I will keep on appending. For example, I have got the system message. Once I initialize my agent, I will be having the system prompt. So I will quickly do self.messages.append. Role is a system and the content is my system. Okay, fair enough. This I am setting in my messages list. After initialization, when I will try to call my agent, I need to pass the user message also, right? The user will ask a question, what is mass of the earth? Like that. That message will be passed to this call. And if there is a value in the message, it will basically again append to the same messages. So this list was having the system message already. Now we have appended the user message or the user question. After having system and the user message, our job is to execute or to call our LLM. So we have written another function called execute. It will do what? It will invoke this Grock method, Grock LLM. If you go self.execute, in the execute, we have written client.chat.completions.create the model name and the messages which we have created. Okay, and it will return the response. Once I get the response, what I want those messages to be appended to my messages list. This is how I'm creating a memory right now. So this is list of all the messages. First, it will have a user message, then it will, system message, then the user message, then the AI message. After executing, I will get some response that will set to my as an AI message, assistant message. Okay. So this is my first part. I have created this class, which is having 3 different methods. Now what? Let me go back to my. Now I have to build the most important part of my agent, which is the system prompt. So what I'm telling in my system prompt is you run in a loop of thoughts, action, pause, and observation. Okay. If I don't give this message, it will simply give you an answer to your question as per its capability. Now we are controlling the behavior of LLM. We are saying you run in a loop. Like this is what we talked about. this system prompt. You are running in the loop of thought, action, and observation. At the end of loop, you output an answer basically after end of the loop. Use thought to describe your thoughts about the question you have been asked. Okay, in the action, use action to run one of the actions available to you. These are the actions list. Okay, use action to run one of the actions available to you, then return pause. Observation will be result of the running those actions. Okay, your available actions are calculate and get planet mass. And as I was telling, and some was asking how it will be able to understand if there are multiple tools, which one to call. That depends on basically this particular description. What it says, runs a calculation and returns the number. Uses Python. So to be sure to use floating point syntax if necessary. These instructions are very important. This is name of my tool or the function. And I'm also giving one example. Okay. For example, I need to do 4 into 7 by 3. Then I can do like this. Similarly, for the get planet mass, I'm telling it in order to use this particular tool, you need to give the mass of the Earth or the mass of any planet. Get planet mass, input parameter is Earth, and the description of tool is returns weight of the planet in the kg. Okay, so when we ask our question to this LLM, since it has this, we are passing the system prompt, my large language model will see, okay, this tool basically returns the weight of the planet in kg. So it will use or choose this particular tool. Okay? And I will also give one example session. This is called chain of thought. When you give some instructions in your prompt in order to control the behavior, then it is called chain of thought. How your LLM should think step by step. That is called chain of thought. So I'm giving one session. Question is, what is mass of the Earth times 2? Then your thought process will be, I need to find the mass of the Earth. My action will be get planet mass. And then I will return pause. You will be called again with this observation. We will execute that tool and it will produce some observation. And then once you are given this result, then again you will think, I need to multiply this by 2 based on my initial question. It will think once it get the mass of the Earth, it has to multiply it by 2. Then it will again decide what action it has to take. It has to call calculate function and then return the pause. You will be called again with this. The LLM will be called again after executing that tool with this observation, the output of the tool. And if you have the answer, output it as the answer. This will basically help to exit the loop. Answer, the mass of the Earth times 2 is this much. Now it's your turn. Okay, we have given the example. Now we are saying, now it's your turn. Whatever the user asks a question, now it's your turn to do or behave like this one. So this is very rudimentary example I am giving so that your concepts get very clear. What runs behind the scenes. Today in the market, there are agentic tools which are like no code or low code tools where you can drag and drop the icons, you can call APIs, and you can build AI agents in 30 minutes. I'm not joking. You can build AI agents in 30 minutes, but those agents will not work for you until and unless you understand what is running behind the scenes, what is happening under the hood. So right now I'm telling all these things in a very transparent manner so that you actually know how the things, what is the concept behind these things, what is the thought process, how they are built basically. So that if your low code, no code is not working, then you can actually pinpoint why it is not working. So that thought process is very important, guys. So I'm trying to give you that by going through the very complex route, right? Anyways, so this is my system prompt is ready. My system prompt is ready. My LLM I have created, that class, the agent class I have created. What next? What next, guys? Any guesses? I need to create definition of those tools, right? Right now, I have just given the name of those tools. But what is the definition of those tools? What those tools are doing that I need to do? So this is my calculate. tool. This is my input parameter of a string time. My output is a float. What it will return? It will do eval and operation. If you do 5 cross 4, this eval function will calculate 5 cross 4 and it will return the answer. Okay. So this is the Python eval function. Second, my method is get planet mass. It will take planet as an input and it will return the mass in the form of float. And it has a logic. It's like a switch case. I hope you have worked on switch case in Java. So match planet dot lowercase of the input, and it will say if it is matching Earth, then return this. If Jupiter, return this, blah, blah, blah. This is my logic basically. Here I can do anything. I can call some API as I shown in the PPT, right? You can update some database, you can call some API, REST API, web service, whatever you want to do. So these are set of my tools which I have created. In system prompt, I am just giving their signature, the name of the tools, what they can do. The real implementation I have written outside my system prompt. There can be tons of these 10s or 20 or 50 such tools based on your application. Great. My tools are ready. Now what I need to do, I need to start calling my agent. So what I will do, I have given the agent as a Neil Tyson as a name. I say agent. This is what I'm doing initialization. So there is a difference between initialization and calling. Right now I am doing initialization. So this method will be called. Okay. So I'm saying Neil Tyson is equal to agent, name of my class, which I want to use. And it has two parameters, guys. The client and the system prompt. I will provide those two things. I will give client equal to client, system as a system prompt. Good enough, everyone? And it will get initialized. And once I run this, what has happened? These objects have got created. This client, system, and messages. What next? Now, this is with the loop. Now what I need to do? This is my system prompt. This we have done. This they have given the name as a planet expert. Let me change
You have to call it.
Yeah, we have to call it. I was referring to some other file. So I will just re-execute. Now I need to call it, right? But before that, let's see what has happened, right? If I initialize my agent, as I said, my messages and everything has got initialized. Let's see what is inside
So
my
message. It looks like there is no error.
Yeah. So if you go into my message, in this one, what we have done, in init, we have just set my system prompt in my messages, isn't it? I appended in the messages role as a system and content. So if I step into my messages object, I will see you run in a loop. It has a role system and the content is you run in a loop of thoughts, whatever system prompt we designed that has now been passed to my agent. Good enough, everyone? What next?
So,
yeah.
Surinder, just one question. This system prompt, whatever you're mentioning right on top. So, is there a specific format that you have to follow or kind of a syntax?
Yeah. So building a system prompt is a very complicated task. What you need to do is you need to use some iterative process, right? At the first place, you will write some rudimentary prompt and then you will run your agent. You will see, okay, this is not behaving well. There are some limitations. You will tune. So you have to tune your prompt iteratively, basically. You have to do hit and try until you reach to a prompt where you get the right answer. And yes, the way is like this only. Once you build a couple of applications, you will be very much habitual of how to write the prompt. basically you are giving the instructions, right? You run in a loop of thought. Your instructions should be very clear. And then we are giving the list of tools, the description of the tools, name of the tools, and then one example session. So this is the format,
Okay.
but it's not like at the very first time you will be able to hit the right prompt. It's an iterative process.
And the actions that you are mentioning there, there in the prompt. So the name, I think the same tools has to be mentioned below, right? That's will it take based on the name directly? So whatever you are
Yes,
mentioning
yes.
the tool, because okay.
Okay, we will, I mean, let me execute. I think it will be more clear. So I initialize my agent. If I look into my messages, one message is there, which is a system message. Okay, good enough. Now I will call my print result. Okay, before that, I need to call my agent. My planet expert has been initialized. Now I am calling. When I do this parenthesis and then question, that means I am calling my agent. So if I run that, what is the mass of Earth times 10? And if I print my result, it has produced a thought basically, right? I need to find the mass of the Earth. Okay, this is how we designed our applications, isn't it? We said in the system prompt that you have to run in a loop. So this is the first part of the loop. I need to find the mass of the Earth. What next? Now, if I look into my messages, what should be there, guys?
Append, I think.
Yeah, it must have appended the user question as well as the assistant answer, right? Because when we called our agent, this method was invoked underscore call, and first I appended my user question, what is the total mass of the Earth times 10, and then I executed, I called my LLM, and whatever response I got, I appended again into my messages. So first message, second message, and this third message, all three messages are there in my messages list, isn't it? Now what I need to again calling, I'm again calling, but without giving any instruction this time, right? Because I don't want to give any instruction. Now the second part is after thought, there is an action. So it should tell me the action basically. Print result. It should have able to get planet mass, Earth, and pause. Okay. So first it did that particular thing, thought process, and based on the thought process and based on the tools available to it, it decided get planet mass should be invoked, which is with the parameter Earth. Remember, your LLM is never going to call any tool or function. Only thing it is doing is it is just deciding which tool is the best one. Executing or invoking the tool or a function is your application's job or your job. Okay. We have to execute or invoke that. Once we build the application, we will automate it basically. How to get it automated? But right now, I am just telling you, LLM is not going to execute any tool. Even if you give the name of the tools, it will just decide, okay, this is the best tool. And in the output, it is just saying me, this tool is the best one to get answers. We have to execute that tool. Okay. In the next exercise, we will automate this, process also. So right now, what I will do, I will manually call this particular method. If you want to see the messages, you can see that one, but let's move ahead. We are running late. So I will do what? I will call this tool with the parameter Earth, and whatever observation I get, I am just printing it the mass of the Earth is coming out to be 5.97 as per my tool. Okay, 5.97 something, 10 to the power 24. Now what we have to do, we have to give this observation to whom? What we have to do with this observation or output of the tool? We have to give it where? LLM, right? So I can see the messages, but let me skip. So we need to provide this output to the LLM. Right now we are doing it manually, guys, in order to understand the basic concepts. After this, what we will do is we will automate all these things so that. So this is my new prompt where I'm passing the observation. I'm setting observation as the observation variable. This new prompt I'm passing to my agent. Let's print this result. Now it will again generate a thought. I need to multiply this by 10. Got it? Now we have to, then it will tell us which tool to call basically. Planet expert prompt. Now it will tell me the name of the tool. Why it needs to be run twice. Okay. Now I will manually call this particular calculate function with this input parameter, and it will give me this observation. Again, I will pass this observation to my LLM. The mass of the Earth times 10 is this much. This is my final answer. So if I go tap into my messages, I can see all those messages got appended to my this thing. Initially my system message, then my user message, what is the mass, then the thought process, then the action, the observation, again the thought process, then the action, then the observation, and this is the final answer. So you have seen how we have created this particular agent where it's deciding which tool to call. And it's basically based on the observation, it is deciding which tool to call until the final answer is goal is achieved. But there are some limitations you have seen. Each time we have to basically execute this manually, isn't it? We have to run our tool manually. So how we can automate this basically? Simply, right? Whenever we are getting this particular response, this thing, we can create one loop in the Python where I will say, if I'm getting this response from my LLM, where it's mentioning me this action and this pause, I will just parse this output and I will call that particular function with this argument, and whatever output is there, I will pass it to the LLM until it's over. समझ में आ रहा है सबको? Now my next step is to automate this particular loop. Right now I was executing the tool manually, isn't it? बोलो तो yes, no.
Yes, sir.
Or you or you lost the
Yes, sir.
interest.
Yes, sir.
ठीक है? So
So
yeah.
I wanted to share something. Like,
Mhm.
so for this coding, we are actually using some existing APIs, right? We're not building anything from the scratch.
Yeah, I mean, we are building everything from scratch at least. I mean, we are using APIs also. Yeah, I mean,
Yeah, yeah.
yeah. So see, we have a large language model. So we have APIs for that to call the LLM, but we are
Okay.
writing the agent class. We are deciding its behavior by the prompt, and we are also calling these tools. We have written the definition of the tools as well. So we are doing all this stuff.
So we're assuming that those APIs will never break, right? It will be
Yeah.
always available.
Yes.
And there is no security threat sharing the data with those. I mean, is there any guarantee that those APIs will not use the data we'll be handling
Correct. So I
during
mean,
this?
those try and catch things we need to put right. So once we build our agent, we have to take care of all those things. If that is not available, if you are getting 404, you have to do those try catch things basically. You have to put your
Okay.
code in the try, you have to catch the exception. Based on the exception, you have to take the action. Maybe you can give it LLM back that okay, this API is not available, then it may think of some other solution. Okay. So all those guardrails, those if and buts we have to handle. It just like any other application, right? In the Java or C application, which we used to write earlier, we have to put all those things, right? If there is an exception, you have to catch the exception. You have to create the logs as well. People will go and see into the logs, where is the issue, things like that. Again, nothing
Okay.
is, I mean, that's where we come, right? Our role is there to build these applications, to make sure these applications runs fine. If not, then we will debug it.
Okay.
Okay, so now our aim is to automate this application to write something which can, we need not to, execute these functions one by one. So I am initializing this with the Neil Tyson. What was the earlier name? Earlier name was something else. Planet Expert. Now my name has changed. I have changed the name to the Neil Tyson, and I have written this code where I am telling maximum how many times it has to. Let me explain you. So I have imported regular expression, and I have defined one loop basically. Okay. And the maximum iterations are 10. The query it will take as an input. And this is, we are initializing our agent. We are created the set of tools. These are the tools which are available. This is the user question, which is going into the next prompt. This is our counter. While I is less than maximum iterations, what it will do is it will call this agent with this prompt. It will print the result. And if in the result, whatever we are getting from the agent, we have the word like pause and action, I will do regular expression, right? And I will try to get the name of the method which is it has returned and its arguments. The chosen tool out of this tool set, which tool our agent or our LLM is asking us to call, the name of that tool and the argument. Once I have that, what I can do is I can iterate through my tools to see or to invoke my tool. I will invoke my tool by using eval function. This is the name of the tool. This is the argument. Whatever result I will get, I will put in the observation. This will become my next prompt. And if somehow the name of the tool or something has gone wrong, it will go into the next observation tool not found. And it will basically print and it will continue this loop. Okay. If finally, if there is an answer, if in the if in the LLM output there is an answer, we will break this loop and we will come out. Let me try to run it. And in order to invoke, what I need to do, I need to call this function. Let's say this time my question is, what is the mass of the Earth plus the mass of the Saturn and all that times 2? Right. So now you can think there will be how many loops? There will be 3 loops, right? So let's call this. Let's see. I need to find the mass of the Earth and Saturn. This is my Earth. Action is my Earth. Observation is 0. Saturn and Earth. Calculate. It seems I got an incorrect value of the mass of the Earth. Let me try again. Earth, get planet Earth. Okay. So this time it was able to recover from the error and got the mass of the Earth and then the mass of this. One time it has got 0 and then it next time also it is 0. Let me try again. So there is some issue with the code. Let me do it. Okay. Something is breaking. Why there is a space? There is a space, right? That is causing the problem. Okay, I think this regular expression is not working. This is an extra space basically. When I'm doing this thing, choose
There is some special character or something. You can just type it as well.
this tool. I'm calling this tool. I need to do this strip. Okay. Still it is there. Okay, maybe I'm printing before that. Okay, so this has arrived to the final answer. The mass of the Earth plus the mass of the Saturn and all that multiplied by 2 is 1.14, 10 to the power 27. Got it? So it has gone into the loop 3 times. First, it will calculate the mass of the Earth. This is the mass of the Earth. Then the thought process is, now I have the mass of the Earth. I need to find the mass of the Saturn. It will calculate the Saturn. Now I have mass of the Earth and Saturn. I need to add them together. So it will invoke the calculate tool. Once it has calculated, then it will again calculate to multiply it by 2, and then final answer will be ready. So this is your first agent, guys. Okay. So we have automated. Now all we need to do is we need to invoke this agent with our question. So if we change our question, let's say I simply do multiplied by 10, and if I change the Saturn to maybe some Mercury, okay, so it will be able to give me the answer. Got it?
Surendra, sorry, what was the issue with the code? I missed
So
that.
yeah, so the
What
issue
did you
was,
fix?
yeah. So issue with the code was that this regular expression is not proper, right? Whatever parameter it is calculating, the name of the Earth or name of the planet, that was having some extra space. So what I have done is I have stripped that particular, truncated the extra space.
Okay, thanks.
Okay. So this is your first agent, guys. So practice this one. And in the next class, as I said, we will use LangGraph to automate this further. So right now, everything we are doing is using simple Python, but we will use the framework to overcome all these things. We will create those start nodes. We will connect those nodes with the other nodes. We will put our conditions, and our life will be much more easier. And we will also add some other functionality to our rudimentary agent, which we have created today. Okay, we will add the memory, we will add how to do human in the loop, how to interrupt, all those things we will do one by one. Today we have learned what is an agent and how to build a basic agent, which can do what? Which can, based on your question, it will think, it will reason, it will decide which tool to call, it will go into iteration, it will tell you the arguments. Right now, what we are doing, we are using the regular expression. And as you have seen, this is not foolproof, right? We got the exception, isn't it? So this is not foolproof. So there is something called as tool calling or function calling. We will understand that concept of tool calling or function calling, where these LLM have inherent capability to provide us the name of the function and the argument it has to call. Right now, from response, we are parsing, right? We are using regular expression to parse the name of the tool and the arguments. In the next class, we will learn how to do tool calling or function calling. Okay, which LLMs, most of the LLMs support. In that case, it will just tell me the name of the method and its arguments in a JSON format, which is easy to parse and which will be foolproof. Okay, everyone. I hope you got something out of this. You learned something out of this particular session. I know it was a bit technical, bit code heavy, but this is the basic basically, right? If you are using some loop, yeah, if you are using some, there is a framework called N8N. So if you are using such frameworks, what will happen? You will just drag and drop, and you will never know what is happening behind the scene. What is the right? You can just drag AI agent, Anthropic chat model, memory, Entra ID, Jira software. You can do all these things. Anyways, yeah, someone was asking a question.
I mean, can you just summarize today's learning?
Yeah. So
Thank you.
today what we did, we first of all, we understood what is an agent is. Agent is something which can basically automate the loop, basically. Automate the loop in the sense when we are asking any question to the LLM, we go to and forth, right? We couple of times we say, do it like this, do it like that, I need this format, and so on and so forth. So what we want it to automate. So creating agent is like building some applications which are autonomous, who can do some complex tasks, not just question answer, but they can do some complex tasks. They can take your input, they will split your task into subtasks, and then it has access to some tools, it has the reasoning capability, it will decide its plan, and it will do all those subtasks one by one, right? And it has a memory with the help of which it will adapt to the user gradually over the time. All in all, the industry is moving towards creating agents who are basically autonomous, who can do some reasoning, who can decide the how it has to behave, how it has to call the different tools, right? All those things. And over the time, it will learn also from the environment. It will take some feedback and it will learn. So over the time, it will improve by itself, right? So we started creating some rule-based chatbots earlier. Then we ended up using RAG, and now we are creating agentic AI applications. Okay, so we saw what is an agent, what is a React pattern. The best way to learn agent is to think of a React pattern, which is like, this is the React pattern. Think through the problem, choose a particular action, execute that action, get an output of the action. That is called observation. Give it back to your LLM. The LLM will decide, okay, this was my aim. This is what I have got. What action I need to take next. So it will keep on doing this loop until it reaches to the final conclusion or the final answer before it exit and give the answer to the user. This is called React, reasoning and action. Okay, we learned about the React pattern. We also did hands-on. We used Grock API to build or to use the LLM which are deployed on the Grock platform. We created one Python-based agent class. We use the system prompt and we use the React framework to build an agent which could basically solve our problem, right? Which could dynamically decide which tool to use, which could reason the problem, decide the tool, and give us the final answer. In the next class, we will learn how to do all these things using a framework like LangGraph. Okay. Anyone has any questions before we wrap up for the day?
And a very high level, we have executed the codes, just dry run.
Correct, correct. So over the next 3-4 classes, we will gradually use the different capabilities of the LangGraph to put new features in this, basically our agent, right? One by one. Okay.
Surinder, how many hours of commitment is needed per week? And what is the basic skill that is required to learn?
Yeah, I mean, agentic AI, you can basically learn if you have some good knowledge about, since we are also doing it on the LangGraph, right? Which is from the LangChain. So if you're starting today with me to learn this particular thing, you should know some basic Python, plus you should know some basics of a large language model, how they work, what is prompt, system prompt, assistant, messages, right? How they behave, some high level idea of the LLMs, and also some idea about the LangChain framework, because you will be using it from the next class onwards. Okay. So if you go, there is something, a framework called LangChain. Okay, so there are a lot of concepts like, what is, they have their own platform, they have LangChain API, LangGraph API, lot of integrations with the different vector databases. There is a lot. I have covered this actually in my course, in my earlier classes. If you want to learn, you can also head towards my YouTube channel. There I have created detailed sessions on the LangChain. If you go to the playlist, there is a playlist for LangChain, advanced LangChain. So this is on advanced LangChain. They are very small videos, 10 to 15 minutes videos. Apart from that, this is, I mean, you can start from here. If you want to learn LangChain, you can go through all these things, how to create LangChain messages, how to use Grock API, what is runnable interface, what are output parsers. So this knowledge of this framework is very much required if you are starting learning to agents,
Okay.
basically.
Okay. Okay. Thank
All right, so I will share this link of my GitHub so that you can also try all these things your own. Okay, it has two files. One is without loop and other is with a loop. Okay, don't go with this LangGraph. This we will cover in the next class. All right, everyone. If you are not having any questions, maybe we can wrap up today.
Thank you.
Thanks,
Thank you.
everyone.
Thank you.
Thanks. Bye.
Okay,
Bye.
thanks, Surendra. Yeah.
Bye.
And you will share the recordings, today's recording?
Yeah, I will share. I will share that.
Okay. Okay, thank you.
Thanks, everyone. Bye.